Today I'll talk about Dalton's law, Amagat's law and van der Waals equation, and finally I'll show pressure percent is equal to mole percent is equal to volume percent for an ideal gas mixture. Now first I'll talk about Dalton's law. So Dalton's law of partial pressure. So Dalton's law states that the total pressure exerted by a gaseous mixture is equal to the sum of the partial pressure of the individual component gases. So mathematically P is the total pressure is equal to sum of the partial pressure. So PA, PB and PC are the partial pressure of the component gases like A, B, C respectively. So here is the example. Like a gas mixture contains 2 moles of oxygen and 3 moles of nitrogen at a total pressure of 500 kilopascal. Calculate the partial pressure of each gases. Now first we have to calculate mole fraction. So first, what is mole fraction? So mole fraction is nothing but individual mole by total mole. So now here that mole of oxygen, oxygen mole is 2, oxygen is 2 mole and nitrogen is 3 mole. So total number mole is 2 plus 3 and in oxygen is only 2 mole. So mole fraction of oxygen will be individual mole, means 2 mole of oxygen plus total mole 2 plus 3. So that is 0.4. Similarly mole fraction of nitrogen, so mole of nitrogen is 3, total mole is 2 plus 3, 5, so 0.6. Now apply Dalton's law. So now this is still now I'm not talking about. So partial pressure is nothing but total pressure into mole fraction. So Na is the mole fraction. Now here apply Dalton's law. So partial pressure oxygen is mole fraction into 500 kilopascal, so 200 kilopascal, and partial pressure of nitrogen, so that is 0.6 into, so this is the mole fraction and this is the total pressure. So 0.6 into 500 kilopascal, that is 300 kilopascal. So partial pressure are 200 kilopascal for oxygen and 300 kilopascal for nitrogen. Now Amagat's law of additive volumes. Amagat's law states that the total volume occupied by a gas mixture is equal to the sum of pure component volume of the component gases. Like mathematically V is equal to VA plus VB plus VC plus ... where V is the total volume and VA, VB, VC are the pure component volumes of the component gases A, B, C respectively. Now here another example of Amagat's law. A gas mixture contains 1 meter cube of hydrogen, 2 meter cube of helium and 3 meter cube of argon. Calculate the total volume of the gas mixture. So here V is nothing but that VA plus VB plus VC. So V of hydrogen, V of helium, V of argon. So 1 meter cube, 2 meter cube, 3 meter cube, total is 6 meter cube. So total volume of the gas mixture is 6 meter cube. Now van der Waals equation accounts for the non-ideal behavior of the real gas. So van der Waals equation is P plus A by V square into V minus B is equal to RT. So here A and B are the van der Waals constant for a given gas and V is the molar volume. Now here is the one example. So here A is given, so that is A is 0.364 pascal meter to the power 6, B is equal to 4.27 into 10 to the power minus 5 meter cube, T is 300 Kelvin, V is 0.0224 meter cube and R is 8.31474 joule per mole Kelvin. Calculate the pressure. So P plus that A by V square, V minus B is equal to RT. So now plug all this and then doing the operation, P will be 110,863.12 pascal. Next, relationship between volume percent, mole percent and pressure percent for an ideal gas mixture. Now consider a gas mixture with component gases A, B, C. So B is the total volume of the gas mixture, P is the total pressure exerted by the gas mixture, VA, VB, VC pure component volumes and PA, PB, PC partial pressure. So for component gas A, so PA into V is nothing but Na into RT. So from here PA is equal to Na RT by V. Now so we know that according to Dalton's law, P is equal to PA plus PB plus PC. Similar way we know that P into or PA into V is equal to Na RT. So similarly PV into V NB RT, so PC is equal to into V, so NC RT. So now if you add, so that will be V into PA plus PB plus PC is equal to Na plus, that is Na plus NB plus NC RT. So now that PA plus PB plus PC is equal to that will be Na plus NB plus NC by NC into RT by V. So that this sum of the partial pressure is nothing but total pressure. So now dividing by total pressure, PA by P, so will be Na by Na plus NB plus NC. So that is called mole fraction. So individual mole by the total mole. So now from here if we multiply both sides, so that will be pressure percent. So PA by P is equal into 100, that is mole fraction Na by total mole NT into 100. So that is what pressure percent of A is equal to mole percent of A. Now Amagat's law application. So V is equal to VA plus VB plus VC. So again similar way, VA by VB, so that is Na by Na plus NB plus NC. So that is mole fraction of A. Similarly we can tell that mole percent, that volume percent is equal to mole percent. So from that we can write volume percent of A is equal to mole percent of A is equal to pressure percent of A. So if we know the volume percent of A, so we can easily tell that mole percent of A is that and pressure percent of A, that is all are equal. Now here one example, consider gas mixture of 40% oxygen and 60% nitrogen by volume of at a total pressure of 1 atm. From here so that 40% oxygen and 60% nitrogen by volume. So now from here we can calculate, so P, that oxygen is nothing but mole fraction into total P. So now we know the mole percent is equal to volume percent. So from that we can calculate partial pressure. So that is 0.4 into 1 atm. So 0.4 atm, 0.6 into 1 atm. So 0.6 atm. Now pressure percent of that oxygen. So partial pressure by P into 100. So 0.41, that is 100%, 40%. So we can say that for ideal gas, pressure percent is equal to mole percent is equal to volume percent. That's it. Thank you.